Hello my dear students, welcome back to my class, Easy Maths by Sukumar. How are you my dear students? See my dear students, in the last class we have solved exercise 10.1 in circles for CBSE students. Now we are going to solve exercise 10.2 in same chapter, circles. Before we start this exercise 10.2, I request everyone, please like, share and subscribe my channel and don't forget to write in the comment box also. Thank you very much. Actually, it's been long time to upload the second video. I couldn't get time to upload the second video. I will try my level best to, whenever I get the time, then I will upload and make the videos for you. Thank you very much. See my dear students, here to start this exercise 10.2, let us, before we should learn theorem number 10.2. Theorem 10.2. This 10.2 theorem says the lengths of tangents drawn from external point of a circle are equal. The lengths of the tangents drawn from external point of a circle. External point of a circle are equal. The lengths of the tangents drawn from external point of a circle are equal. See my dear students, here there is an external point, that means outside of the circle. Here it is an external point. The two tangents are drawn from the external point of the circle. So these two are the tangents which are drawn from the external point of a circle. This is P. P is an external point. Here this A and B are the point of contact. That means PA and PB are the tangents of the given circle from this external point. So we have to prove here these two tangents drawn from this external point of a circle are equal. That means here we have to prove that PA and PB are equal. PA and PB are equal. So my dear students, this is the center of the circle. This OA, what is OA here? The distance between center of the circle to the point on the circle. That is the radius. So this OB is also radius, OA and OB. Okay. So my dear students, what is given here? Here what is given? Here O is the center of the circle. Center of the circle, and OA and OB are the radii of the circle. OA and OB are radii. Here the main point is PA and PB are the tangents drawn from an external point of a circle. PA and PB are the tangents. PA and PB are the tangents drawn from the external point of a circle. See my dear students, what we have to prove here actually? We have to prove here, this PA is equal to PB. PA and PB are equal. That means the two tangents are equal. We have to prove that these two tangents are equal. Okay, let us make a small construction here. So what is the construction here? The construction is very simple. Just join this OP. Join this OP. Right. Finished. See my dear students, now actually we know that from theorem 10.1, the tangent and radius at the point of contact, the tangent and the radius at the point of contact, this is the point of contact, is right angle or 90 degrees. That means angle PAO is 90 degrees. Similarly, angle PBO or angle OBP is also 90 degrees. See my dear students, here take the two triangles. In the proof, take the two triangles. One is triangle OAP, another triangle is OBP. So in triangle OAP and take the triangle OBP, the second triangle OAP and OBP. Just we take the two triangles and make it congruent. Then we can write that PA and PB are equal according to CPCT. Okay. So now our aim is to prove that triangle OAP and OBP are congruent to each other. Okay. So the first step here I am taking is OA is equal to OB. That OA and OB are the radii of the circle. Okay. Since the reason is radii of the circle. Radii of the circle. Radii of the circle. OA and OB both are the radii of the circle. And next, my dear students, OP is the common side. Is it the common side for both the triangles? OP is the common side for triangle OAP and triangle OBP. Okay, so OP is the common side. OP is equal to OP. In the both the triangles, this is the common side. And what next, my dear students? As I told you, according to theorem 10.1, the tangent and the radius at the point of contact is 90 degrees. That means angle OAP is 90 degrees. Similarly, angle this OBP is also 90 degrees. Angle OBP is also 90 degrees. Angle OAP and angle OBP is 90 degrees. Therefore, my dear students, according to what? Side angle. That means SAS congruency. Triangle OAP is congruent to triangle OBP. Since, what is this criteria? SAS congruency rule, the two triangles are congruent. Okay. Whenever the two triangles are congruent, according to the CPCT, that means corresponding parts of the congruent congruent triangles are congruent. That means here this PA is equal to PB. This PA and PB are equal according to the CPCT, right? Therefore, hence it is proved. So that means this PA and PB are the tangents drawn from the external point of a circle. It is very important theorem even for the state board, AP state board students also. Okay, please write down. Okay, so far we have learned two theorems, that is theorem 10.1 and theorem 10.2. The theorem 10.1 says in a circle, the angle between radius and the tangent at the point of contact is 90 degrees. Based on the theorem, we are going to solve exercise 10.1 as well as exercise 10.2 also. My dear students, just now we have learned what is the theorem. Theorem 10.2. What is the theorem states? Tangents drawn from the external point of a circle are equal. That means we proved that PA and PB are equal. Okay. Now, my dear students, in this exercise 10.2, in this 10th chapter for what? CBSE students, the first question is, in question 1, 2, 3, choose the correct option and give justification. Okay. The question is, first one is like this. From a point Q, the length of the tangent to a circle, is 24 centimeters. Okay. And the distance of Q from the center is 25 centimeters. The radius of the circle, what is the radius of the circle? Okay. See what is given here. From a point Q, here there is a point Q here. The length of the tangent to a circle is 24 centimeters. That means this is the length of the tangent. So just let it be A. This AQ is equal to 24 centimeters. Of course, this is the radius. This is called radius. And this is the distance between, OQ is the distance between center to the external point of a circle. Okay. And what next here? What is given? The other point. The distance of Q from the center is 25 centimeters. That means this OQ is 25 centimeters. That means AQ is equal to 24 centimeters and this OQ is equal to 25 centimeters. See, you know, my dear students, the angle between this tangent and the radius at this point of contact is 90 degrees according to theorem 10.1. Okay. Now what we have to find the radius of the circle. So OA is the radius here. Actually this OA is the radius. See, my dear students, this triangle OAP is a right angle triangle. Why it is a right angle triangle? Since this angle OAQ is 90 degrees, therefore this triangle OAQ is a right angle triangle. Okay, so we can apply the Pythagoras theorem. Since it is a right angle triangle at A, so we can apply Pythagoras theorem. So what is the hypotenuse in this triangle? In this right angle triangle. So OQ is a hypotenuse. Why it is a hypotenuse? It is opposite to the right angle. Therefore, this OQ is called the hypotenuse. So my dear students, according to Pythagoras theorem, okay, so OQ square is equal to OA square plus AQ square. OA square plus AQ square. This is Pythagoras theorem. The square of hypotenuse is equal to sum of the squares of other two sides. So my dear students, we know what is OQ, that is 25 square. It is equal to OA square is the radius of the circle and AQ is the length of the tangent, that is 24 square. So 25 square means 625 is equal to OA square plus 576. OA square is equal, just make it a subject OA here. OA is the radius. So OA square is equal to 625 minus 576. So this is equal to 49. So OA is equal to square root of 49, that is plus or minus 7, but we take only the positive value of radius. That means OA is equal to, that means radius is equal to 7 centimeters. 7 centimeters. I hope you understand this sum, my dear students. Here this is actually justification. This we call justification. So just find out the option here. A is 7 centimeters, B is 12 centimeters, C is 5 centimeters and D is 24.5 centimeters, but the correct option is A, that is 7 centimeters. Coming to the second bit in this exercise 10.2. If TP and TQ are two tangents to a circle with center O, so that angle POQ is equal to 110 degrees, then angle PTQ is dash, PTQ. Okay, that means this angle. See here, my dear students, you know that angle OPT is 90 degrees and angle OQT is also 90 degrees according to theorem 10.1. The angle between the tangent and the radius at the point of contact is 90 degrees. So my dear students, this OPTQ is a quadrilateral. This OPTQ is a quadrilateral here. Is a quadrilateral. Just I am writing justification here. See, this OPTQ is a quadrilateral. Therefore, the sum of the four angles, interior angles of a quadrilateral is 360 degrees. That means actually this angle is 110 degrees. This angle POQ, that is 110 degrees. Angle P is 90 degrees. And angle PTQ. Angle PTQ is unknown, that only we have to find here, and this angle Q is 90 degrees, again 90. This sum of all these four angles is equal to 360 degrees. Okay, see here, just I use this 10.1, here also the theorem 10.1. So and I also use the sum of the interior angles of a quadrilateral is 360 degrees. So my dear students, here 90 plus 110 is 200, 200 plus 90 is 290. That means angle PTQ is equal to 360 minus what? 290. So this is equal to 0. 16 minus 9 is 7. So here this is 70 degrees. So what is this angle, my dear students? This is 70 degrees. I hope you understand this. Here this OPTQ is a quadrilateral. So the sum of the four angles of a quadrilateral is 360 degrees or four right angles. So my dear students, this angle is 110, but this angle is 90. Why it is 90? The angle between the tangent and the radius at the point of contact is 90 degrees. So 90, this is unknown, that is angle PTQ, this is 90, again 90. Okay, so this is this sum of this 110 plus 90 plus 90 is 290. So 360 minus 290 is 70 degrees. Okay, now coming to this last third sum in this space 213. If tangents P and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degrees, then angle POA is equal to dash. Okay, actually the figure is not given in my dear students. Okay, let me draw the figure first. P and PB are from a point P to a circle with okay, P and PB are the tangents. Okay, please look here. This PA, this is A and this is B. These two are the tangents. PA and PB are the tangents drawn from the what? Point P to the circle. Okay, that means A and B are the points of the contacts, right? See here, these two tangents P and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degrees. That means the angle between these two tangents is 80 degrees. Okay, so here the angle is, they are inclined to each other like this at an angle of 80 degrees. Okay, now what we have to find here? Find angle POA. So here this is the center of the circle. This is the center of the circle. Just join this OA and OB. So we have to find angle POA. Just join this line also. POA. Okay. So what is angle POA here? Please look here, my dear students. See here, we should find actually angle POA here. Angle POA. Okay, let me write the justification here. The justification. Okay, see here, actually the triangle OAP and triangle OBP are congruent to each other. We already proved, to prove that the tangents drawn from external point of a circle. In theorem 10.2 we already proved there. That means in triangle OAP is congruent to triangle OBP, and we proved that these two triangles are congruent. We already proved, we know that, this is we know, already we know that. And angle APO is equal to angle BPO. Angle APO and angle BPO are equal. Since the two triangles are congruent according to CPCT, these two angles are congruent. That means, what about this angle APB? Actually, angle APB is equal to 80 degrees. So what about angle APO, students? 80 by 2, that is 40 degrees. So my dear students, this angle is 40 degrees. This angle is also 40 degrees. Okay. Now take the triangle AOP now. In triangle AOP, angle OAP is equal to 90 degrees. Angle OAP is 90 degrees. Angle APO is equal to 40 degrees. Okay. Now in the triangle, the sum of the interior angles of a triangle is 180 degrees. That means angle A plus angle APO plus angle AOP, this sum is equal to 180 degrees. What is angle A? 90 degrees. Why it is 90 degrees? According to theorem 10.1. The angle between radius and the tangent at the point of contact is 90 degrees. That means this angle is 90 degrees. So 90 plus angle APO is 40 degrees. Here angle APO is 40 degrees plus angle AOP is equal to 180 degrees. So 90 plus 40 is 130. Therefore angle AOP is equal to 180 minus 130. So this is equal to 50 degrees. So my dear students, this angle AOP is equal to 50 degrees. See, actually option A is 50 degrees. So the correct option is 50 degrees. Okay. Coming to the fourth question in this exercise 10.2, prove that the tangents drawn at the ends of a diameter of a circle are parallel. Okay. See my dear students, here it's very simple theorem. See, it's a circle with center O here. This is the diameter of the circle. AB is the diameter of the circle for this triangle. So the diameter of a circle passes through the center of the circle, and also that this is the longest coordinate circle. Okay. See my dear students, the tangents drawn at the ends of the diameter of a circle. That means this is a tangent. This is a tangent drawn at the end of the diameter. And this is another tangent drawn at the end of this diameter of the circle. So we have to prove that these two tangents are parallel to each other. That means let it be this tangent is xy and this is some PQ. PQ is another tangent. So these two tangents are drawn at the ends of the diameter of a circle. That means this is the diameter, AB is the diameter. Here AB is diameter of a circle. Okay, AB is the diameter of a circle, and this XY and PQ, XY and PQ are the tangents, XY and PQ are the tangents drawn at the end points of the diameter, of the circle, end points of AB, since AB is the diameter. See my dear students, here what we have to prove here, to prove this XY is parallel to PQ. Actually XY and PQ are the tangents drawn at the end points of the diameter of a circle. Okay, I hope you understand up to here. Okay, see my dear students, in the proof, look here. See, what is this angle, my dear students? This is a tangent. Of course, this AO is a radius. And this XY is a tangent. According to theorem 10.1, this angle is 90 degrees. Similarly, my dear students, this angle is also 90 degrees. Of course, this angle is also 90. This is also 90. 90, 90, 90, 90. According to theorem 10.1, this is 90 degrees. This is also 90 degrees. I am taking only these two here. There is a purpose here. Okay. So, let me write angle XAO is equal to 90 degrees. XAO is 90 degrees. Similarly, angle QBO is also 90 degrees. The reason here is, what is the reason here? According to theorem 10.1 says the angle between radius and the tangent at the point of contact. This is the point of contact. Here this is the point of contact. This is the tangent and this OB is the radius of the circle. Therefore, this angle is 90, this angle is also 90. So, let it be equation 1 and equation 2 are from above equations, my dear students. Here this angle XAO and angle QBO are equal. Why? Both the right hand sides are equal to 90 degrees. So therefore angle XAO and angle QBO are equal to each other. See, my dear students, I already explained for 9th class students in the previous videos the properties of a parallel lines. If a transversal, this is the transversal, intersected by two coplanar parallel lines, if the alternate interior angles are equal, means then the two lines are parallel to each other. That means here this XY and PQ are parallel to each other. So my dear students, angle XAO and angle QBO are alternate interior angles. They are called alternate interior angles. Alternate interior angles are equal. It happens only when the two lines are parallel. That means XY is parallel to PQ. So it's very simple statement, simple theorem. Here this angle is 90, this angle is also 90. These two are actually the alternate interior angles, but here these two angles are equal. The alternate interior angles are equal means these two lines are parallel to each other. Therefore this XY is parallel to PQ. Hence it is proved. Coming to the fifth question in this exercise 10.2. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. That means take a circle here. See my dear student, this is the center of the circle O. O is the center of the circle. O is the center of the circle. Okay. See here what is given. The perpendicular at the point of contact to the tangent. That means here it is a tangent. This AB is a tangent. This is the point of contact, let it be X. So here the perpendicular at the point of contact to the tangent. That means this perpendicular to this tangent at the point of contact to a circle passes through the center of the circle. Okay. See my dear students, here this perpendicular we have to prove is passing through this center of the circle O. Here what is the tangent? AB is the tangent. AB is the tangent. AB is the tangent, and this OX is what? Perpendicular. This OX is perpendicular to AB. Okay. So we have to prove here this perpendicular to this tangent at this point of contact of the circle is passing through the center of the circle. Okay. See my dear students, here just I produce here like this. Please look here, proof. See, this angle is 90 degrees. You know that angle OXB is 90 degrees. Why this angle OXB is 90 degrees? According to theorem 10.1, the angle between the radius and the tangent at the point of contact is 90 degrees. So angle OXB is 90 degrees. Similarly, this is, let it be C, this point is C. Angle BXC is also 90 degrees. Angle BXC, this angle OXB is 90 and this angle BXC is also 90 degrees. Okay. Just make it, add the two equations. Angle OXB plus angle BXC is equal to 90 plus 90. So that is equal to 180 degrees. So that means this sum is equal to 180 degrees. So this sum is 180 degrees means OXC is a straight line. Is a straight line. Is a straight line. Moreover, this OX and C are what? OX and C are collinear points. What are collinear? Collinear means the points lie on the same straight line are called collinear. Therefore, this perpendicular is passing through the center of the circle. Okay, that means therefore the perpendicular of AB passes through the center of the circle. The center of the circle, O, right? So that means these 3 points are collinear. That means O, X and C are collinear. Therefore, this XO is the perpendicular of AB. That means this perpendicular passing through the center of the circle. Hence, it is proved. Sixth question in this exercise 10.2. The length of a tangent from a point A at a distance of 5 centimeters from the center of a circle. That means the length of the tangent at a point A at a distance of 5 centimeters from the center of a circle. This is 5 centimeters. Is 4 centimeters. That means this length of the tangent is 4 centimeters. Understand the sum very clearly, my dear students. Here the length of the tangent is given, that is 4 centimeters, and the distance between the center to the point A is 5 centimeters. So we should find the radius of the circle here. Okay. See, let it be some P here. Now in triangle POA, in triangle POA, angle OPA is equal to 90 degrees. So what is the hypotenuse here? OA is the hypotenuse. So according to Pythagoras theorem, OA square is equal to OP square plus PA square. Since Pythagoras theorem. Okay. So what is OA here? This is 5 centimeters. That is the distance between the point from point A to the center. So what is OP? This is the radius of the circle. What is PA? 4 square. That is the length of the tangent. Okay. So 25 is equal to OP square plus 16. 4 square is 16. 5 square is 25. Okay. We have to find OP. OP is the radius. That means 25 minus 16. So OP square is equal to 9. So OP is equal to square root of 9. So OP is equal to plus or minus 3. Therefore, the radius of this circle is 3 centimeters. Explain this. Look here. See, this A is the external point of the circle. The length of the tangent from A to P is 4 centimeters and the distance between the center to the external point of a circle is 5 centimeters. So we have to find the radius of the circle here. So how do you find the radius of the circle here, my dear students? According to Pythagoras theorem, actually this OPA is a right angle triangle. Since this angle OPA is 90 degrees, angle OPA is equal to 90 degrees according to theorem 10.1. Okay. Now OA is the hypotenuse. So the square of hypotenuse is equal to sum of the squares of other two sides. That means OA square is equal to OP square plus PA square. So 5 square is equal to OP square plus 4 square. So 25 is equal to OP square plus 16. So OP square is equal to 25 minus 16, that is 9. So OP is equal to square root of 9, that is equal to plus or minus 3. So OP is the radius is always positive. That means radius is 3 centimeters. Okay. Seventh question in this exercise 10.2. Look, two concentric circles are of radii 5 centimeters and 3 centimeters. Okay. There are two concentric circles. One is of radius 5 centimeters and other one is radius of 3 centimeters. Okay. So these two are the concentric circles. They are like a ripples in the water tank or pond. Okay. So one is 5 centimeters, other one is 3 centimeters. Find the length of the chord of the larger circle. So length of the chord of the larger circle which touches the smaller circle. Okay. So we have to find the length of the chord of the larger circle and which touches the smaller circle. That means this AB is the chord of larger circle, but this AB is the tangent of the smaller circle. Okay. So what is given here, my dear students? this O is the center of the circle. O is the center of the circle, right? AB is the chord. AB is the chord of larger circle. AB is the chord of larger circle, but it touches the smaller circle, means this AB is also what? Also the tangent. Also the tangent of smaller circle. AB is also the tangent of the smaller circle. So this AB is the chord of the larger circle, but it touches the smaller circle, means it is a tangent. Why it is a tangent? It meets the circle at exactly at one point. Okay. So we have to find this length of this AB now here. Okay. Now just join this OA and OB. See, this point of contact is here. Let it be some P. Just join this PO also. I will write all these constructions here. What I did here? Join OP and also join AO and BO. AO and BO. And join this AO and BO. So my dear students, here take the two triangles. Triangle OAP and triangle OBP. In triangle OAP and triangle OBP. OAP, OBP. Take the two triangles here. So just we'll prove that the two triangles are congruent to each other. Actually, what is given, my dear students, here? The radius of the smaller circle is 3 centimeters. This OP is 3 centimeters. Here this OP is equal to 3 centimeters. And this AO and OB are the radius of the bigger circle. That means this OA is equal to OB is equal to the radius of the bigger circle, that is 5 centimeters. So here this OP is 3 centimeters. OA and OB are equal to 5 centimeters. So my dear students, take the two triangles OAP and OBP. Here let us prove that these two triangles are similar. So how do you prove here? This OP is equal to OP is the common side. This is the common side for both the triangles. And here OA is equal to OB. This is the radii of the bigger circle. Radii of a bigger circle. Bigger circle of radius 5 centimeters. And we know that angle OPA, according to theorem 10.1, OPA and OPB is equal to 90 degrees since theorem 10.1. Okay, so therefore my dear students, triangle OAP is congruent to triangle OBP since RHS congruency rule. Right angle, hypotenuse and side. Therefore the two triangles are congruent. So here these two triangles are congruent. Actually this is 5 centimeters. That means that AP and BP are equal. AP is equal to BP. Okay. See my dear students, in triangle OAP, since it is a right angle triangle, then we can apply Pythagoras theorem. That means AO square is equal to OP square plus AP square. That means AO square is what? 5 square is equal to OP square is 3 square plus AP square. So 25 minus 9 is equal to AP square. So AP square is equal to 16. AP is equal to square root of 16, that is equal to 4 centimeters. So what is AP, my dear students? 4 centimeters. But AP and BP are equal. AP and BP are equal to 4 centimeters. Therefore the length of the tangent of the smaller circle or the length of the chord of a bigger circle, that is AB, is AP plus BP, that is 4 plus 4, that is 8 centimeters. Therefore the length of the chord of a larger circle is 8 centimeters. Eighth question in this exercise 10.2. A quadrilateral ABCD is drawn to circumscribe a circle. Here this circle, a quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. Okay. See here, let us see the proof here. See my dear students, now we are going to use the theorem 10.2. So far we did not use the 10.2 theorem. Okay. See, this AP and AS are the tangents. Look here carefully. AP and AC, observe here, AP and AC are the two tangents drawn from point external point A. Similarly, this BP and BQ are also the tangents drawn from the external point B. Okay. Similarly, this CQ and CR are the tangents drawn from this external point C. Similarly, this DR and DS are also the tangents drawn from the external point D here. Okay. See my dear students, according to theorem 10.2, tangents drawn from the external point of a circle are equal. That means here this BP and BQ are equal. BP and BQ are equal. Similarly, this AP is equal to AS. Similarly, here look, this CR is equal to CQ. CR is equal to CQ. Similarly, there is DR is equal to DS. DR is equal to DS. The only reason here is tangents drawn from the length of the tangents drawn from external point of a circle. External point of a circle are equal. That means here this BP is equal to BQ, this AP is equal to AS, and this CR is equal to CQ, and this DR is equal to DS. Okay. Now by adding these equations, by adding these four equations, look, BP plus AP plus CR plus DR, it is equal to BQ plus AS plus BQ plus, just I will make it, first I will write CQ here. Okay. BQ plus CQ plus AS plus DS. Excuse me, right. Look here, BP plus AP, CR plus DR is equal to BQ plus CQ, AS plus DS, just by adding the four equations, that left hand sides and the right hand sides here. Okay. See my dear students, here this BP plus AP is equal to AB. So this is AB. Similarly, this CR plus DR, just look here please, CR plus DR is CD. So this is CD. It is equal to, look, BQ plus CQ is BC. This is BC plus this AS plus DS is AD. Okay. That means what is to be proved here actually? To prove this AB plus CD is equal to AD plus BC. Okay. So already this AB plus CD is equal to BC plus AD. Hence it is proved. Did you understand, my dear students? Here it's very simple. Here A is the external point of the circle. So AS and AP are the tangents. Similarly, BP and BQ are equal. CR and CQ are equal. DR and DS are equal. So BP, BQ equal. So AP is equal to AS. CR is equal to CQ. DR is equal to DS. Just by adding these four equations, that left hand sides and right hand sides, we will get like this. Just one thing you keep your own mind. Here AP BP just write in left hand side. Similarly, this dr and cr is also write in left hand side. This side, that means the sides AD and BC, just write in right hand side. Try to write in right hand side. Then your job is very simple. By adding these two, then BP plus AP is AB. This BP plus AP is AB. CR plus DR is CD. Similarly, this BQ plus EQ is BC. This AS plus DS is AD. Therefore, hence it is proved